engineer.
Exactly. Okay, so today we are working on unit 5.1. Okay, so we're on 5.1. And what we're going to be doing today is simplify and solve radical expressions. So most of what we're doing today is just simplify. Okay, there's going to be a lot of simplify and then some solve towards the end. So if your instructions are to simplify, let's start off with a little bit of review. Actually, everything that we're doing today is review. Okay, so simplify, I want you to simplify root 75. Now, this is actually called a radical. Okay, we don't call it a square root because it's not always going to be a square. Okay, so a radical, this technically, does anyone know what the number is here in the handle? There's actually a 2, okay? And that invisible 2 tells you you have to have 2 of the identical things underneath here broken down to get out from under that radical, okay? We don't write it. Usually it's just kind of like if you write a number, we don't always have to write a plus in front of it. We just know that it's positive, okay? So that's just one of those things that we always know is there. This breaks down, what does 75 break into? You could do 15 and 5 or 3 and 25, doesn't really matter. Either one would work. Now, once you've broken something down, I would cross it out because that way you won't break it down too many times. Then 25 would break into 5 and 5. Now remember, with a radical, with a square root, you have to have 2 of the exact identical things to get out from underneath the root. This one, you can take out a 5, and left behind is a 3, and that's it. Okay, that's our answer for today. 5 root 3. So the first part, we're just breaking things down, and that's it. You guys remember this?
Yes.
You did this in Algebra 1. This, most people do pretty well with, okay? Because that's what was left behind. When I broke it down, 75 broke into 3 and 25. 25 broke into 5 and 5. And remember, you have to have 2 of the exact identical things to get out. Okay? Have you guys ever heard, do you know why you have to have 2 identical things? Okay, this is kind of like Sadie's. Who's going to Sadie's? And this week, next week? Okay. To go to Sadie's, you have to be, you usually are dressed alike, right?
Sure.
Okay. This is kind of like radical Sadie's. Okay. To get out of the house, this is the house. Okay. This root, it's a house. To get out of the house, you have to have a buddy. Okay. You have to have someone that you're going out with. You have to be identical. You're dressed identical. Okay. If you're not identical, if you don't have a buddy like this 3, you have to stay home. You have to stay in the house.
Dijon.
You just have to stay in the house. Okay? If you have a buddy, if you have an identical buddy, you get out of the house. Okay? Anybody that doesn't have a friend, they have to stay home inside the house. It's kind of sad, but it's okay. Sorry. Okay, number 2. How about if I ask you to multiply root 7 times root 35? Root 7 multiplied by root 35. Okay, that was not the most creative analogy I could have come up with, but whatever. Sorry.
I'm confused.
Okay, when you multiply radicals together.
You just recorded yourself saying that whole
I know.
They're probably gonna be like, what the heck is this lady talking about?
Okay, when you multiply radicals together, you do not actually want to multiply this yet. Okay, the first thing you want to do is just rewrite these underneath the same radical. Now, we don't want to multiply them together because when we're finding radicals, we're actually breaking them down. So there's no point in multiplying together and then breaking it down.
Why'd you put
So,
a multiplication sign?
Yeah.
because they would be multiplied. You mean on this one? That's the problem that you're given. Right here?
Yeah.
Because if you don't have the multiplication sign, sometimes people like put them next to each other and it becomes 735. But it's definitely not. Okay? So, then break this down. 35 breaks into 7 and 5. Cross that out because I broke it down. And then we have a pair. So we have a pair of 7s.
So what do you do with the 7?
They get to go outside of the house. Okay, they get to go to the Sadies. So 7, and what's left behind? The 5. Okay, it didn't have a partner, it didn't have an identical to go with, so it has to stay home underneath the house.
Wait, so do we break the one down that has 1 left? 35 could be 1 and 35 7.
Oh, okay, you don't break down the 7 anymore because it can just be 1 and 7. Yeah, so we don't need any 1s. That doesn't really do anything. So that's it for that one. Okay, let's try another one. For number 3, do we have questions?
Why can't a 1 do anything?
If you take out a 1, it's just multiplying by out front. So the 1, we can take out 1 like forever, but it's still just going to multiply and nothing will change. Okay, for number 3, if I give you radical 100 over 169. Guys, stop. Root 100 over 169. If you have a fraction underneath the radical, the first thing you need to do is break it down to be 2 little roots. Okay, so root 100 over root 169. You can't have a fraction underneath the root, so we need to break it down. Then we can break these down even further. What is root 100? 10. Over what is root 169? 13. And we're done. Okay, so we want to break out as many pairs as we possibly can.
This is all, you're not going to add in a bunch of gibberish?
This is the first part of your homework. Okay? Next thing we're going to do is, again, I want you to simplify root 11 over 144. Root 11 over 144. So again, if it's underneath a big radical, I want you to break it into 2 little ones. So root 11 over root 144. And then break down what you can. Can I break anything out of root 11? No, so it stays root 11. Can I break something out of root 144?
12.
That is 12. And that's your answer. Okay, now, this is probably a good time to tell you there's a rule, okay? And the rule is that answers cannot have radicals in the denominator. Okay? It is perfectly fine to have radicals in the numerator, so in the top of the fraction, but you cannot have any answers with radicals in the bottom. Okay, so no radicals in the denominator. I'm going to show you in just a second how we get rid of them. Okay? Number 5, I want you to simplify root 2 over 15. There are 10. Root 2 over 15. Now, anytime you have a fraction, I want you to split it up. So that leaves you with root 2 over root 15. Now, if you can reduce things that are both underneath the radical. Here, nothing can reduce. Is there anything that can break out?
No.
Nothing can break out. Okay, now, I said that there couldn't be any radicals in the denominator. Does anyone remember how to get rid of a radical in the denominator?
Take it out. Break it down.
Well, does this break down to anything? There's no pairs that can come out. It does break down to 5 and 3, but there's nothing that can come out.
Oh, you have to use the 2.
How do you get rid of something? How does something come out from underneath the radical? It has to have a pair, right? So we have to create a pair of 15s. Okay, so what we have to do is something called rationalize the denominator. Okay, we need to do something called rationalize the denominator. And basically what we want to do is we want to create a pair of 15s. So what you're going to do is we're going to multiply by root 15 over root 15. Because what is root 15 over root 15? Basically 1. Okay, and you can multiply anything by 1 and it doesn't change it. So we're just going to change this form and we're going to create a pair. Now in the top, we still have 2 times 15. I'm not actually going to multiply together yet because I want to see if there's going to be any pairs. In the denominator, we have root 15 times 15. And what happens is I get a pair in the denominator, so they get to go out. So in the bottom, we just have a whole 15. Is there anything that can come out in the top? No. No pairs, so we actually do multiply together. So root 30 over 15, and that is your answer. Okay, now keep in mind, this cannot reduce. Okay, this is a radical, So really, root 30 is like 5 point something, and this is a whole 15. You cannot reduce those, okay? Whole numbers can reduce with whole numbers, radicals can reduce with radicals, but you cannot mix the two. Okay, we cannot mix the two. So that's your actual answer there. Questions? Anyone have questions? Okay, next thing we're going to do is, again, I want you to simplify. I would like you to simplify 4 over 5 minus root 2. 4 over 5 minus root 2. Simplify that. 4 over 5 minus root 2. Now, when I rationalized the denominator, I multiplied by, I got a pair, okay? What do you think I'm going to multiply by here? Does anyone remember this from Algebra 1?
No.
Now, do not write this down yet, but I'm going to show you what happens if I just multiply by root 2. Okay, if I just multiplied by root 2, you would end up multiplying here, so we'd get 4 root 2. But in the denominator, I would distribute, and I would get 5 root 2 minus, great, I created a pair of 2's, but I still have a radical, right? That doesn't work, okay? Anyone have any other ideas? What do you think I'm going to multiply by to get rid of that?
Root 4. Oh my god.
Multiply by root 4? No? Any ideas? What you actually have to multiply by here is something called the conjugate.
Oh, I heard that before.
Okay, I know you guys have heard this before. And the conjugate is whatever is the denominator, but change the sign in between. And what ends up happening here is something very similar to difference of squares. Okay, it's very similar to a difference of squares. So you multiply by the exact same thing on the bottom, but change the sign in between. Now, since we're multiplying by the same thing on the top and the bottom, this is really just like multiplying by 1, but I'm going to get rid of the denominator. Or excuse me, get rid of the root in the denominator. So in the top, we just distribute. So 4 times 5 gives you 20, plus 4 times root 2 is 4 root 2. Okay, the whole numbers stay by themselves, the radicals stay by themselves. We don't like intermix them. You're not multiplying anything together. And what happens in the denominator is we're actually going to FOIL. So first times first gives you 25. Outsides gives you plus 5 root 2. Insides gives you minus 5 root 2. And last gives me what? Negative, actually root 4, but we know that that made a pair of 2's. So negative 2. And what happens here is these roots cancel each other out. Okay, so it's a lot like difference of squares. These go away, so if I simplify, we get 20 plus 4 root 2. And in the denominator, what is this? 25 minus 2 is 23. So you can keep that answer because I got rid of the radicals in the denominator. Okay, and that is fully simplified. Questions so far? Yes, Angie.
Do you change the sign every time, or just if it's a negative?
We always change the sign every time. How did I get a negative 2?
Yeah.
Negative root 2 times positive root 2 gives you a negative, right?
Yeah.
So basically that was
Oh,
negative,
the parents, they just
right,
did that?
2 times 2. So we took out a pair, and that became a negative 2. Anyone else have questions before we move on?
Who made these great principles?
I have no idea who made up these principles.